In this module we are going for how to do observational studies data analysis using R. In any epidemiological study, one type of study is called cross-sectional study, or it is also known as observational study, where we just go into field and collect data about individual. No follow-up observations are there. We don't take the same individual data repeatedly over there. Only single time measurement observation taken about the individuals, about the disease prevalence, about the factor, to find out assess the factor associated with that disease. So it is very important to find out the proportion of factors present or proportion of disease present in the study. For that, proportional test is very important. Another important test is proportional trend test, that gives us the idea how one group to another group, or from another group to another group, how proportion keep on changing, and if it keep on changing, is there any positive trend or not, or negative trend or not. So proportional trend test, another important thing that we will see how to conduct proportional trend test using R. We will see here how to perform chi-square test using R, because chi-square is the widely adopted statistical test to find out the relation between two categorical variable. It gives the two categorical variable is associated or not. Like others module, we had give one initial example. Here I will also give the same kind of example, where we are going in the field and trying to find out relation between smoking and cancer, or relation between alcohol taking with cancer. So we can again form a contingency table, 2 by 2 contingency table, and we can perform the chi-square test to find out relation between smoking on cancer, or alcohol or cancer, or other causal factor can be explored through application of chi-square test. So in this module definitely we will see application of chi-square test and how to conduct it using our learning objectives: preparing table in R for observational study, perform proportional test using R, perform proportional trend test using R, and thereafter perform chi-square test using R. So now starts the module. Here there are one observational studies data, and we are using the library mask here, where the table is used as a functions, and into the table survey with smoke and survey of exercise EXR is considered, and this measurement of smoke and exercise is assigned as a table and is given as a TBL. So once we are calling the TBL, it is giving this frequency and number of individuals with heavy, never, occasionaries and regular smokers, with how many of them were doing exercise as a column, and these frequencies is observed here. So this is the typical formations of table for two variable when both of them are in categorical form. Now we will go for chi-square test for this table, and Pearson's chi-square test will be obtained. So if you put the CHISQ dot test with TBL, it will give us this chi-square test value, and x squared value will be obtained, has obtained from these studies as 5.48 with degree of freedom 6, and p value showing 0.4829. So as a hypothesis that is considered that exercise yes or no is having any influence on smoker or not, or smokers are having any associations for exercise yes or no. So it's obtained that there is not any associations for smoking or heavy smoking or regular smoking on exercise. So here in addition to the results, here one alarming message is coming, that is given as warning message. It's showing that in chi-square.test TBL, chi-square approximation may be incorrect. The problem is maybe some values in this text is less than 5. So now we had corrected the TBL chi-square.tbl as CTBL, and combined C bind function is used for TBL with frequency and TBL with none and TBL with some. So now the table is formed as CTBL with first column as heavy, never, occasional and regular, and second column as 1 and third column as 2 for exercise yes and no, and corresponding figures are given like 7, 4, 87, 102, 12, 7 and 9, 8. So again when we perform the chi-square test like chi-square.test with CTBL, we are getting the again Pearson's chi-square test value as p value with 0.3571. So somehow p value reduced, but still it's showing that there is not any significant associations between exercise and smoking. Now we will go for proportion test. Proportion test is widely used when we try to find out the hypothesis that is there two groups is having different proportions or not. This proportion test is also available in the library MAS, where we don't need to install any specific library or package to run this proportion test. When you want to compare two sample individuals like study 1 and study 2, or sample 1 and sample 2 is having different proportion of individuals or not, then this test can be used. It is a simple test. Here in this example we are using the smoker and patient. So first column is assigning as number of smoker were there, that is 83, 90, 129 and 70, and from these patients, those were patient, among them only smokers code came. So out of these 86, 93, 136 and 82. So see, these out of these patient 86, 83 were smoker. Again from 93, 90 were smoker. Again from 136, 129 were smoker, and out of 82, 70 patients were smoker. So hypothesis is that these four proportion, that is 83 out of 86, 90 out of 93, 129 out of 137 and 70 out of 82, these four proportion are equal or not. So this is our hypothesis. So to perform that hypothesis, we took top.test with smoker comma patients. So as a result, we are getting 4 sample tests for equality of proportion without continuity correction factors, and as a result we are getting proportions value are significantly differ. So since p value is coming 0.005585 with chi-square value 12.60 and degree of freedom 3. So it says that those proportion are not statistically same, they are having difference, and proportion 1 is 96%, 0.51, proportion 2 is 96.77, proportion 3 is 94.85, proportion 4 is 85.36%. So these results showing that these chi-square proportion test showing that these proportion are not. Now we will go for proportion trend test. The sample example and same example here is considered. Now earlier we had used purport probe.test. Now we will replace that probe.test as probe.train.test with smoker and patients, and this p-value is coming as 0.004132, and the chi-square trend chi-square value coming as 8.2249 as the calculated chi-square value with 1 degree of freedom. So it shows that again there is a significance difference between these four proportions. Now one initially this say this first functions used is here has not considered this the c of 0, 0, 0 and 1. So if in second function we had used this c with 0, 0, 0 with 1, that is useful to giving the function as scoring. So giving these four proportion as scoring, because initially in first example we can see that using score is considered as 1, 2, 3, 4. Now score is for odd individual is considered 0 and the fourth one is considered 1. So in that case it's observed that chi-square value is 12.17 and p-value having becoming more significant with 0.00048848. Now we will go for test. One in addition to smoker, that is 83, 90, 129, 70, and patient with 86, 93, 136, 82, we are using another variable that is GP, that is standing for group, that is standing for 1, 2, 3, 4, to assigning this group of these four as first, second, third and fourth group. And again we are using the proportion t-test, proportion.test with smoker and patients, and it's showing this chi-square value with 12.60, degree of freedom 3 with p-value 0.005585. So it is assumed with this alternative hypothesis with two-sided. Now another way, now assigning this value as a new example here as dot table, where R bind with value is 762, 327, 468 is considered, and another one 484, 239 and 477. So these are the first observations observed from a survey from few male and female individuals. Those are belonging to party at Democrat, Independent and Republican. So gender is assigned as male, AF as for female and AM for male, and corresponding party order is also given. Now when we are assigning this chi-square dot test with AM, we will get the chi-square value as 30.07 with degree of freedom 2, having highly significance value, and that is coming p-value 2.954 to the power 10 to the power minus 7. So it says that these male and female and this number of individuals goes for belonging to the party Democratic, Independent and Republican, having highly significance difference. So these are example considered here cited from our exercise. Now we are preparing the table form by this here, that number of people observed for gender, that is male and female belonging to Democratic as 762, Independent Party as 327 and Republican Party is 468, whereas male belong to Democratic is 484, Independent 239 and Republican 477. Now we are going for expected count under the null hypothesis, and this expected value coming by applying the chi-square value is coming 703.67 as compared to 762. Again independent it is coming 319.64 as compared to 327. Again female with Republican coming expected value as 533.68 as 468. Again for Democratic it's coming 542.32 from as observed as 484. Again, independent for male is coming 464.35 as 239 for male, and for Republican male it was 477 and expected it is coming 411.31. So these are the Pearson residuals observations obtained from these expected minus observed square by expected 1 for chi-square value, and these are the standard residual value observed from this data. We are preparing another example where to perform these chi-square test where effect of simulation as p-value is considered, where the matrix is formed for observation 12, 5, 7 and 7. So it is having 2 multiplied with 2 contingency table, where first row first column is having observations 12, first row second column is having observations with 5, second row first column is observation having 7, and second row second column is having observation with 7. Now this table we are assigning and putting chi-square dot test with x having p-value, and p-value showing with 0.4233049. Again it is showing that there is not any tendency or association between these 2 by 2 table. Now this p-value can be simulated p-value can be obtained, and we are not going into details here that were the simulations, but it's a procedure where we can generate as much as possible data we want to generate from the basic data. So here we are as a B we are assigning 10,000. So 10,000 number of sample data we are assigning for to get the chi-square test value. So simulations can be done as chi-square dot test with x comma simulate dot p dot value equals to true. By default it will not take, so we have to assign as true comma b equals to 10,000 with p dot value. So it will give us the p value as 0.2936706. So initially our p value was coming 0.42, but when we had done some simulations, then we had got the p value from 0.42 to 0.29. So it's the simulations can be more. Here we had done for 10,000 sample size simulation, so simulation can be done for 1 lakh or more than also, and once we will increase the simulation, the standard error of mean estimate will decrease. So this is the handling to how to simulations of p value or chi-square test value significance difference between two variable through simulation we have noticed here. Now we will go to another example. Here we are assigning the variable a equals to 20, b equals to 15 and c equals to 25 as variable x, and we are considering the chi-square dot test. We are getting the probability comparison with chi-square equals to 2.5 degree of freedom 2, p value 0.2865, where chi-square dot test as dot table x giving us the probability for this table, and p value again coming as 0.28565. So both way we can perform this table, one as chi-square dot test of x and another one is chi-square dot test with as dot table x. Now another example, see here only we are using a x. Now in addition to x we will using the p, and we will see how these error terms are obtained. So this p value can be used as a error term. So let's see, x assigned as 89, 37, 30, 28, 2, and p is assigned as 40, 20, 20, 15 and 5. So try parenthesis chi-square dot test parenthesis x p equals to p will give us this result, and as a result we are getting here the p value is 0.04. So that's showing these proportions, that is first proportion that is 40 out of 89, second proportion 20 out of 37, third proportion 20 out of 30, and 15 out of 28 is having different probability is of proportions, and that is coming 0.04. Now again another example, we are going for application of chi-square where we are assigning p as 0.40, 0.20, 0.20, 0.10, 19 and 0.01, and expected count category is considered as 1.86 less than 5 to perform the chi-square. So approximations observed as x comma p equals to p, where chi-square test of this value given as 5.7947 with degree of freedom 4 and p value 0.215. Again this result is warning this approximation may be incorrect. So now we had altered this chi-square dot test as x comma p equals to p for the approximation test, and as a simulate dot p dot value equals to true we have considered. So here we are not mentioning number of simulations should be there, only simulate should be done we are mentioning here, and as a result we are getting p value equals to 0.1899 with chi-square value 5.7947. and as a default, if you don't mention the number of replicates should be done, as a default are considered is as a 2000. So this message also coming here, chi-square test for giving probability with simulated p based on 2000 replicates has been done. Now another, we are generating data from uniform distributions where funct C function is used for 5 multiplied uniform of 100 samples, and these sample assigned as x. Now the chi-square dot test of table x is performed, and this Excel sheet there showing the significance difference between these expected value and observed value, and this p value showing there is not any significance difference between expected value or observed value. So it is quite obvious that when we are generating data from random sample and we are comparing the data with some again from sample, so there should not be any significant difference between sample value. So that's why the p value is coming 0.47 and chi-square value is coming 3.5. In this module we have seen how to prepare table using R for observational study. Thereafter we have seen how to perform proportional test using R, and we have seen how to conduct proportional test using R, and we have also seen how to conduct the chi-square test statistics using R to perform or to find out the association between variable. I think you may also use these functions in other domain or other area where is having same kind of hypothesis as well same kind of data setup conducted through the field survey. Field survey is useful in any other different domain, not only in medical research or epidemiological research, and for all this kind of survey research this mentioned tool can be easily adopted to solve your hypothesis or to support your research goal.